Section 5.5 Interactive Assignment, Objective 4. How many different 10-letter words, real or imaginary, can be formed from the following letters? Now, to create a word from a given set of letters, we are arranging the letters in a certain order. However, in this case, we have the added complication that we have been given some letters which are duplicates of each other. Since we can use each of the 10 letters we have been given only once, replacements are not allowed. In this situation, we count permutations of non-distinct items without replacement. Now, a permutation of non-distinct items without replacement is the number of ways n objects can be arranged, where order matters, in which there are n subscript 1 of one kind, n subscript 2 of a second kind, and n subscript k of the kth kind, where n is equal to n subscript 1 plus n subscript 2 plus n subscript k, and the number of such permutations is given by the following formula. So we have n factorial over the one kind of letter, so we have n1 factorial times n2 factorial all the way to nk factorial. Now, before we make our formula, we need to determine, okay, how many letter words do we have? Well, we know that we have 10 letters. So we know that from the problem, we know that it's a 10-letter word, so therefore n is going to equal 10. Okay, then we have to look at each letter. So first, are there any duplicates here? We can see that there's a duplicate here for D and then D. Okay, so we have two duplicates here, which are D and D, and therefore, since there are two D's, that means that n subscript 1 is going to equal 2, because there's two of them. Okay, next we have two K's, 1 and then 2. So that means that there are two K's, so the value of n subscript 2 is going to equal k. Okay, next we have two V's. So there are two V's, so the value of n subscript 3 is going to equal 2. Okay, next there is one F, so the value of n4 is going to equal 1. Okay, if you notice here, we have one Y. So therefore, there is one Y, so the value of n5 is going to equal 1. Okay, and then we have another one. We can see that we have one I. So therefore, we're going to say that there is one I, so the value of n6 is going to equal 1. And then the last one is going to give us the following. You can see that we have one P, so therefore there is one P, so the value of n7 is equal to 1. So now this tells us, okay, the number of distinct, okay, values that we're looking at, non-distinct, excuse me, okay? And so therefore, what we want to do now is we now want to write this formula out. So we have n factorial, and if you notice that we have n1, n2, n3, all the way to n7. So it's going to be n factorial times n2 factorial times n3 factorial, all the way to n7 factorial. And then we're going to fill in our values. So if you notice here, we have the value of 10, which is 10 factorial. Okay, we can see that there's n1 factorial, there's n2 factorial, and again, we can just go up here and highlight so that we can match each one. Okay, and then we have n3 factorial, and then we have n subscript 4 factorial, and then n subscript 5 factorial, n subscript 6 factorial, and n subscript 7 factorial. So those are all the numbers that are associated with the numbers that we have here. So you can see there's 2, there's 2, there's 2, 1, 1, 1, and 1. Okay, now the next thing is we want to make sure we can evaluate. So in our numerator, we're going to have 10 factorial. So 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3. And we're going to stop at 2 factorial because we have a 2 factorial over here. So therefore, we can simplify those two to 1. Okay, now recall that 2 factorial is the same thing as 2 times 1, so we have 2. 2 factorial again is 2, and then 1 factorials are just going to give us 1. So now we need to figure out, okay, well this 2 times 2 is going to give us 4. So 2 times 2 is going to go into that 4. And now what's remaining? Well, what's remaining is the following. We have 10 times 9 times 8 times 7 times 6 times 5 times 3. And that's all over 1. When we multiply all those numbers out, we get 453,600. So we would say that 453,600 10-letter words, real or imaginary, can be formed with the given letters. And therefore, if you take a look at our result on my stat lab, that verifies our result.